Assalamu alaikum guys, this is Mohammad Gashuddin. Welcome to the GFC. So guys, I am talking to you or I am delivering my lecture from the Thermodynamics. Guys, today what will I discuss? Today I'll discuss additive process, okay? PV to the program equal to constant. We have to prove this. How can we prove this? Because P here, pressure V here, volume, and this is the ratio, okay? And this is gamma, and we have to prove this, guys. How we can prove this? Very simply, we can prove. For proving this, we have to know some basics, guys. From the first law, from the thermodynamics first law. Do you know what is the thermodynamics first law? Actually, very simple, guys. dq equal to du plus pdv or dw. Okay, simply we say dw. So guys, we have known dq du plus pdv. This is the first law, thermodynamics first law, and this is the internal energy. Internal energy. Okay, and this is actually volume change, and total this part is called work done. Okay, work done, whether it is negative or positive, external or internal. Okay, work done. And guys, this is actually required energy applied or delivered heat. Okay, provided heat, actually heat, guys. dq equal to du plus pdv. Guys, we will take actually system in the actually system, and this is dq, this is du, this is from the thermodynamics law. Guys, very simple. If you know about the heat, then you can understand the first law. Actually, from the practical life, you could see this application of first law. First, well, how can you actually think and this? Okay, guys, this is dq, this is du, this is pdv. It's very simple. Very simple. Just if you go to kitchen, you can understand actually dq equal to du plus pdv. Guys, if you have water and if you take some water and heat that, then you can see after certain time the cover of the what goes through, because there is created a pressure by the heat. Okay, that means when you provide heat, that is dq, you have provided dq heat to the pot. Okay, and you are making hot the water. That means there is a changing internally. That is du, internal energy, and that has been done and work. How can their work has been done? Because there is created a constant pressure P, and dV, the volume change of the water. Okay, that means by applying the pressure, water volume has been changed. That's why we could say that has been done work. Okay, that is PdV. Guys, the cover of the pot goes away. That means that has been done our work. That's why cover after certain time of providing heat or internal energy changing, that cover of the water goes away. That is work. Okay, so simply from that example you can understand this thermodynamics first law. Guys, it's very simple. dq is provided it, du is actually internal. Okay, fine. Our target pv to the power gamma equal to constant. Okay, this will improve. Okay, here dq, just now I have said this is adiabatic process. That's why here dq equal to 0. Since it is adiabatic process, and since we improve p to the gamma equal to constant in adiabatic process, that's why adiabatic process dq equal to 0. Guys, here again another point or quantity we have to know, that is du equal to cvdt. Okay, this is specific heat due to the constant pressure, and this is change of temperature, and d is the internal energy. That means just now we have known this for adiabatic process, and we have known this for specific heat due to the constant pressure. Yes, this term, this two terms we have to remember. Okay, by remembering this two terms, we could some solution. How? Okay, we could do some solution. The dq equals 0, that means 0, and here d equal to cv dt and pdv. That is, we have got this line. Now we have to do another line. But what is that? Very simple. Just now I've said we have to know some basics. Okay, that is actually like this. PV equal to RT. Guys, so this is Ball's formula, and we have to know this. And by this, we'll find out PdV plus VdP equal to R del T. This is very simple. One equation, and this we got by differentiation. By differentiation, we got this. Okay, we have done here differentiation. There is a p dv plus p dp, and here del RT. That means del T equal to p dv plus v dp upon R. This will be needed in the equation 1. Okay, that's why we have found this delta equal to p dv plus v dp. This delta value could put here. Okay, here 0 cv, and delta means p dv plus v dp upon R. Okay, and plus p dv plus p dv. Yes, very simple. Now, what can we do? CV, this, R, and this. Okay. Now, okay. Let me do this. Okay. Now, R, uh, PdV, PdV, R plus CVPdV plus CVBdP, and we have divided both sides by R. Okay. That's why we got this C equal to 0x. Okay, nice. Fine. Now we know, guys, I said that first we have to know some basic, and here we have to know what's the value of R. Okay, BdV, R here Cp minus Cv, Cp minus Cv plus CVPdV plus CVBdP equal to 0. Okay, fine. We have put the value of R, and this is the basic. Okay, that means we've got three basics, four basics here. dq equal to 0, and d equal to cv del t, and pv to rt, and now we've put here the r equal to cp minus cv. These four basics we have to understand to remember. Then we could solve this algebraic. Okay, algebra. Okay, nice, guys. CPTP, that is PBCP PDV minus CVPDV plus CVPDV plus CVPDP equal to 0. Nice, here DV cancel. This CVPDV cancel. Okay, that means CP PdV plus CV VdP equal to 0. This is online, which will be needed for doing something. Anyway, if we divide it both sides, guys, here we have to remember another formula, that is Cp upon Cv equal to gamma. Okay, this line we have to know, and we have to remember. That means we have to divide it both sides by Cp upon CV. Okay, PdV plus VdP equal to 0. Okay, nice. Here gamma PdV plus VdP equal to 0. Okay, nice. Sorry. Here PdV, why PdV, why PdV? CP PdV, 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 PdV. Okay, nice. Now we will divide both sides. Let me delete this. Actually. Okay, both sides by PV, that means gamma V dV plus P, sorry, 1 P P plus dP here 1 upon V. Guys, this line we've got. Now, what can we write down here? We can write down uh, gamma ln V plus ln P plus constant. Okay, constant you can write down C. Guys, here integration. We have done integration both sides by doing integration both sides. Okay, by doing integration. Okay, by integrating we could do this. Okay, that means here we can write down ln p to the gamma plus ln p equal to ln c. Guys, here ln b gamma p ln c, we can cancel ln from both sides. That means b to the power gamma p equal to c constant. This is our required line. B to the power gamma equal to constant due to the adiabatic process. Guys, if you know the gamma V P, or if you know and the state of P or gamma P, then you can find out the second volume of that system. Anyway, just remember this P V to the gamma equal to constant. Such way we have deduced finally. Okay, guys, for doing this algebraic methodology, we have to remember dk equal to 0, d equal to cv dt, dv equal to rt, r equal to cp minus cv by cv equal to gamma. And we have to remember integration and differentiation. First time I did differentiation, then I finally did integration. By integration, we got this line finally. Guys, that's all today. Assalamu alaikum.